Hello guys, so this is the first episode of this new series about shaders in OpenGL, basically GLSL, the OpenGL shading language, and it's been requested since a while and it's actually pretty interesting. So let's go ahead and start with this new series. And in the first episode of new series, you usually just talk about boring stuff like how to set it up, and this is what we're going to do right now. So before we can actually write the shaders, we need to kind of set them up in LibGDX so we can actually see what they do and if we are doing things correctly or just messing things up. So at first, make sure that your useGL 2.0 or this variable here in your configuration is set to true, because we cannot use OpenGL 1.x for this because, well, shaders have been introduced in OpenGL 2.0. The rendering pipeline has been closed before, but now we can insert our own shaders and do awesome stuff. So set this to true, otherwise you'll get a null pointer exception, which is kinda unnecessary. So let's go ahead and create a shader program. This shader program is going to be applied to our sprite batch, which actually uses a shader program already, but we've never seen it. It's the default shader program. So, well, at first let's go ahead and actually create the shader program. So shader equals a new shader program, and it takes two files, actually two file handles. The first one is going to be the vertex shader. So gdx.files.internal shaders passthrough.vsh for vertex shader, and the next one gdx.files.internal is the fragment shader, so shaders passthrough.fsh. So these shaders do essentially nothing. It's kind of boring, but they're shaders, so that's what the series is about. The next thing that you want to make sure is that you have shader program.pedantic set to false. If it's set to true, the sprite batch will try to send all kinds of information to the shader, basically all information that it has. And we don't need that at all. We just create a basic shader that displays stuff the way it is. It's going to try to send this to your shader program, and the shader program is not made for it, as you will see in the code this or next episode, and we'll just get crashed. So let's say we now want to use this shader. For this, we're going to get the sprite batch from the renderer and set its shader, not its blend function, set its shader to, well, the shader. Who would have guessed that? But before we can print out some information, if the shader is compiled, if it's compiled, then we'll just say shader compiled, yay, and if not, we'll say shader.getLog, and in this log we'll see all the errors, so we can go and fix them. Okay, so since our shader is compiled and we set it to the renderer, well, to the renderer sprite batch, we can actually go ahead and try it already. And there we go. Isn't that beautiful? We got the map rendered on the screen. I just noticed that we cannot move it around because I was stupid and forgot to set the input processor to this. And that's it. Now we can move it around, we can zoom in and out, and we basically see no effect of the shader at all because it's, like the name says, a pass-through shader, so it just, you could imagine it lets the pixels through. So we want to change that because it's pretty boring. So let's have a look at this pass-through shader file. It's not here. Pass-through.vertex shader. Now what is this? This is the OpenGL shading language, and before we actually get to such a stage, we want to create our own little shader that's a little bit more social to our new learning brains, and we'll just call that red, because it's just going to render red on the screen. This sounds even more boring, but we'll need it. Okay, so in this project's shaders here, we'll just go ahead and create a new shader. Now I have a plugin installed to actually have a little bit of syntax markup and stuff in my shaders, and I will give you the link to that plugin in the description. So once you got that installed, you can actually type, like normally you'd have Java projects and stuff, but then you can search for shader, and we'll see fragment shader file and vertex shader file. Now we want to create both because we always need both, but at first let's go with a fragment shader. The container is simply the location, which is in GLSL Shaders, desktop, assets, shaders, and we'll call it red.fsh. Now they already put some stuff here, but we'll not care about that and just go ahead and create a new one, a vertex shader, also called red, in the other file here, GLSL Shaders desktop, assets, shaders. Okay, and they already put some stuff here as well. So let's just get rid of all of that. Well, basically of almost all of that. For example, this here, we don't need this, we don't need this, we don't need any of this. Well, we do need it, but we want to write it ourselves. So you can let this ifdef GLES here, but I would recommend to set it to medium P then, because that's kind of faster and still, well, precise enough. This is basically an if function in GLSL before out of all these methods. So we actually don't need this. Let's just not confuse ourselves and just get rid of it. We don't need to pass in void here, we can just not pass anything in here, and we don't need to do this. We just want to create a red shader. Okay, so what's this all about? This is obviously not Java, this is GLSL. And in GLSL things work pretty differently. GLSL is a language only made for shaders, and has a whole lot of functionality that's useful for shaders, but nothing else. So at first, let's go about the theory. So what is actually happening with this fragment shader, vertex shader, and just everything? Well, shaders work this way. Let's imagine you render a sprite. Actually, let's go ahead and render a sprite so you can imagine it. Let's go back to a passthrough shader, and let's go ahead and render some sprites. So, well, there are sprites. Let's pick one of these bricks here, for example. This brick is a sprite, and it's being rendered on the screen. Great. So now what the shader does is at first we use the vertex shader, and the vertex shader is applied to all vertices of this sprite. So there's this vertex in the top left here, that vertex there, that one there, and that one on the top right here. So the vertex shader is going to do stuff with these vertices. We get some information and we can set variables. That's basically it. We can also change the position of the vertex to like get wobbling effects or water ripples or any kind of cool stuff. But for now, we are just going to not touch these vertices and just move on to the fragment shader, because after the vertex shader, that one right here, it goes to the fragment shader, that one right here. Both pretty boring at the moment, but yeah. So the fragment shader is also called pixel shader sometimes, and that's because it is actually running, this main method is actually called for every single freaking pixel on the screen. So this is a 1280 times 720 screen here, window. So it's actually called this many times for every frame. Sounds absolutely crazy, but that's how it is. Rendering is something complicated. Okay, so it's called on every single pixel, and that makes it pretty interesting because we can basically edit anything. We just set the color of the pixel, but we could apply sepia, vignette, I don't know, inverted colors, everything. That was just really basic examples. So now that you know that we first take these four corners and then every single pixel on the screen, let's go and actually take these four corners and pixels and, well, do stuff. And the first thing that we want to do is nothing. So as you can see, you probably think if you see these empty methods, okay, we don't do anything, so the pixels just appear like they are right now on the screen. But no, actually, this is just going to, I don't know, it's probably going to crash. But it's definitely not going to render like this. Because these two programs are part of the whole pipeline in the OpenGL drawing stuff. So we have to do some OpenGL work here, and if we don't do it, OpenGL doesn't do it for us, and it's just not happening. So at first, in the Fragment shader, we have a few variables. Now variables work a little bit differently than in Java, because there are 3 spaces where you can put variables in. The first one is the attribute space. It's like, you could imagine 3 different hard drives or buckets or whatever you want to imagine. And attributes are given to us by OpenGL, and they're stuff like, well, now for data types, I'll just say vec3 or vec4. Explain in a second. The first one is, for example, the color of the vertex. So I'm prefixing this with a underscore, so we know that it's an attribute all the time. It kind of makes sense because we might have multiple colors, and it's just useful to do it like that. Now, what about this? We don't initialize this or anything because well, it's already being given to us by OpenGL, but we need some place to actually put it, and that is the attribute space. Attribute variables are finals, so you cannot assign a new value to them. That's pretty useful because we don't want to do it. So now about the data types. GLSL has a few very useful data types. At first, void. Well, I don't have to explain that, I guess. And then all these vecs. So we go with vec1. No, that makes no sense. But with vec2, vec3, and vec4. Vec5, no. So just vec2, 3, and 4. They're like vector 2 and 3, and there is no vector 4 in LibGDX, but that's what it would be. So it's basically just x and y again. Then we have the float data type. Also, well, that's pretty obvious. And I think we also have no, we don't have a double, whatever. We have a float. And we have an int. We might have several more. I'm not the best shader writer. Maybe I have stuff like, okay, I'm coming from Java and trying out everything. But we have these few data types. Also, there are matrices. So GLSL supports matrices and vector multiplication, subtraction, addition, and everything out of the box. We don't have to do all that complicated stuff ourselves. It would be a pain in Java, but it's awesome in GLSL. So, for example, we have mat2, which is a matrix of the size 2 and 3 and 4, no 5. Okay, so we will use the mat4 at some point, but not right now. For now, we just need a few more attributes. For example, let me think. The vec2, so that's just x and y, a text chord 0. So we have to actually follow these exact names here, because OpenGL is trying to give these exact things into this renderer, into what am I saying? Into this shader. And if they don't exist there, it doesn't know where to put them, and we get an error. So we need to follow these names. We can edit them in LibGDX, but why would we? They are good. Let me think. Is there something else? Oh yeah, definitely. The attribute vec3 a position. That's what it's called. So what are all these? At first, vec4 is a color, and a color consists of red, green, blue, and alpha. So, well, that makes sense to have 4 spaces there to put stuff in. So red, green, blue, and alpha. Then the vec3 has x, y, and z, which is the vertex position of, well, the 4 vertices I just showed you on the brick. And the vec2 just holds x and y because it's simply on a 2D texture. Yeah, it doesn't need any more. Then, what else do we have? We have 2 more spaces to put variables in. So like I said, there is this attribute space, but there also is the uniform and varying space. So for example, the uniform space would be something that we don't need in the vertex shader. So let's just not do it. Let's just care about the varying space, because we always need that in the vertex shader. Varying is something that the vertex shader and the fragment shader share. So if we call like vec4 vColor for varying, now we can choose these names ourselves, they are not given like the attribute ones. We create a vec4 called vColor in the varying space, and once we are done with this vertex shader and it goes to the fragment shader, we can actually go ahead and say varying vec4 vColor. So we're just taking the exact same variable out of the varying space again. What else do we want to give over there? Yeah, we also want to varying vec2 a text chord 0. So I'm just calling that actually v text chord 0. I'm just calling that text chord 0 because I just want to keep this name so we know what we're talking about. But we need this texture coordinate in the fragment shader to actually be able to show the pixels color. We do need a uniform variable in here, and that's the uniform made for u proj trends. Great, isn't it? So that stands for projection transformation, and that's a matrix with a size of 4, as you can probably see from the data type, and that is given to us by the sprite batch, not OpenGL this time. It's given to us by the sprite batch. So what's a uniform anyway? We know what a varying and an attribute is, but what's a uniform? A uniform is basically normal variables like we have them in Java. So these varying are going to pass over to the vertex shader. The attributes are final ones that we just get from from OpenGL, and the uniform ones are not going to pass over to the fragment shader. That's pretty important, and they are not final, and we can actually communicate with these uniform variables in code. So if we're in here, we are actually going to do this in a few minutes, I think, or in the next episode or whatever. We can set this uniform variables in our GLSL shader from the Java code. So, alright, we know that the sprite patch gives us this U projection trans, so we don't have to do it. But what is the U projection trans? Well, it's basically just renderer.get sprite patch dot what am I doing? Get projection matrix. That's what it is. So it's a projection matrix. Okay, so it's good for you to know, and we will have to use this. So what do we want to do in the fragment shader, in the vertex shader now? Want to prepare our varying variables for the fragment shader, so we can use them in here. So that's actually a pretty simple job. We just need to assign vColor to aColor, actually aColor to vColor, and vText chord 0 to a text chord 0. And one more thing, that's actually the a position. Well, yeah, right. GL underscore position. Well, what's GL underscore position? We didn't set it anywhere up here. That's because GL underscore position is a built-in variable in GLSL that we can set to actually set the position of the vertex. So we already have the position of the vertex. It is a position up here. So we are just saying a position. So now we used these, and all of these, but we didn't use our nice projection transformation here, or metrics. And that's because you know that in the Java code we are using a camera, and that camera also has all these matrices, and matrices are pretty useful in graphics programming anyway. So what we want to do is we want to transform our position according to our matrix, so the camera and everything is applied correctly. So like I said, metrics and vector multiplication and addition and subtraction and division, I don't know if that's even possible, is already out of the box in GLSL. We can already do it by simply saying u projection trans times a position, and that's it. There's nothing like the multiply like in Java, just multiply, because that's all built in. So that's pretty nice. So what are we doing? We are getting 3 attributes: the vector 4, which is the color of the vertex, and a vector 3, which is the position of the vertex, and a vector 2, which is the texture coordinate of the mapped texture to this vertex. Then we get a uniform matrix 4 from the sprite batch, which is called u projection trans. I think we can actually edit this name in Java, but why would we? And we have these 2 varying variables that we want to set in order to be able to use them in our fragment shader here. So this method is going to be called for every vertex on the screen, like for all of the 4 vertices of the sprite. And at first we want to set our varying color to the color that has been given by us. So we don't want to edit the color of the vertices. We could, for example, say we want to darken this down, and we are just going to say a color dot. I know that's actually pretty interesting, but anyway, we could darken this down. So I don't know, or make just the left vertices a little bit brighter than the right vertices, but we just want to take like that and give it to our fragment shader. Then the text coordinate is the texture coordinate that we've been given, so we just want to continue passing that on, which is why this is called a pass-through shader. And the GL position, which is the position of the vertex, is just going to be transformed by our projection matrix that we get from the sprite batch. And well, it's originally the position that we got from the attribute space. So that's all for the vertex shader. Now let's go into the fragment shader. So like I said, we have these varyings here, which we want to take out of the varying space again, and that was the vColor and the vTextCoord 0, that one. So vec2 vTextCoord 0. Now what is our goal in the fragment shader? Our goal in the fragment shader is simply to set the color of the pixel. And to do this, we just need to say GL frag color, and it already highlights it like this, like, whoa, this is your goal, that's what you want to do, equals some stuff. So for example, we could say vColor, but that would make no sense at all. So our goal is to set GL frag color. For this we need a bunch of stuff. For example, another uniform. Actually, that's the only thing we need. And it's just going to be another data type that I didn't explain previously. It's called a sampler 2D. So what the hell is a sampler 2D? Now it's getting complicated. That's what I thought when I first saw it. And let's just call this u sampler 2D. So a sampler, like the name kind of suggests, samples single pixels or something else, I don't know, from textures. So we use this to actually get the pixel from the texture, the saved file that we have. And well, it's now in memory, but anyway, we use this to sample the color of a pixel from the texture to then be able to apply it to GL frag color. So we want to set GL frag color to something using the sampler. So now we have to use a built-in function. These functions are not from objects or anything. This is not really object-oriented. It's a C-like language, so we just have this built-in function here in GLSL called texture2D. And it already highlights it like this yellow stuff, so we know it's a function. And it takes 2 variables. We don't see that anywhere, but we know that it takes 2 variables, and that is the sampler, uSampler2D. So it uses the sampler to actually sample the pixel from the texture. And the next thing is the vText coordinate. So it actually knows where to use the sampler on the texture. So this is a coordinate on the texture at which we want to sample something, and from this we get this color here from the texture2D function, which is returning a color, in case I didn't say that, and I think I didn't. So we want to take this times our v-color, because v-color is a vec4 of the vertex color. So if we would like to set a sprite's color to black, we would set all the v-colors to black in our Java code. That's what we're actually doing if we're saying sprite.setColor black. And then we multiply the color that we used in code by the color of the texture at that position. And that's actually it. That's all we need to do. And now you're wondering, we didn't ever initialize this use sampler to D. Well, don't worry, we have to go like new sampler to D. That all doesn't exist. It just tells GLSL, alright, we want to use the sampler to D. There we go, there it is, have fun with it. And I think this is actually enough already. And you know what we just did? We said we would like to create a shader that just displays red, but we actually made a shader that displays the original stuff. So that's cool. If you understood until here, that's actually pretty cool. And I don't know if this is actually our shader right now. Let's have a look. Yeah, we are using the previous one. Let's say red, because that's the one we just wrote. And see which awesome errors we get. We get errors. What is the problem right here? So we see in 0, I don't know what that means, but in line 13 of some file, we don't even know which file, we have a size mismatch for matrix multiplication. And that is over here. I know, because that's the only place where we use matrix multiplication. And if you have a look, U project trans is a matrix 4, and A position is a vector 3. So we have to create a new vector 4 in order to be able to actually like multiply them, because you cannot multiply a vector of the size 3 with a matrix of the size 4. They have to be the same size. So now how do we do that? I said there is nothing like new, so we don't have like new vector 4 and have constructor. No, that's all not existing. We just have to specify vector 4, give it the vector 3, and append 1.0. Or like I said, 1 or 1f, but I prefer 1 dot in GLSL. So actually, I'm gonna be social and use 1.0 for you guys. So yeah, the vector 2 kind of constructor takes all kinds of things. We could say just 1.0. This would be equal to 1, 0, 1, 0, 1, 0, and 1, 0. It would set all the values of the vector to the one that we put in there. But we can also say we give it a vector 3, for example with 0, 0, 0, and then another one. And this is actually what we're doing. We're giving it a vector 3 called A position, and then the last one. So you could imagine this as x, y, z is defined by A position, and w is defined by 1.0. So we don't need w at all, which is why we just set it to 1.0, so nothing changes, because if you take anything times 1.0, it just stays what it is. Okay, so now we should be able to actually see it. And there we go. We have the exact same thing as before. But I don't want to disappoint you, and we'll actually go ahead and get rid of this here. Well, we'll just let it, but in order to set something to just the red, we could say vec4 1.0 for red, green, blue, and alpha. So this is what a red shader would be looking like. Great, isn't it? Everything that we render is red. Every single freaking pixel is red. Great. But that's pretty boring, so let's get back our actual map here. And you see, we don't even have to change stuff for that. Okay, let's get rid of this log stuff here. And, well, that's how to create a basic pass-through shader. I hope this tutorial was not too long, and I hope you learned something from it. And I think when you're learning a new language, there's often many questions, so don't hesitate to yeah, ask your question in the new Google Plus fucked up comment section, and I'll see if I'm gonna be able to reply to them if Google Plus allows me to. Yeah. Anyway, so thanks for watching this video, and I hope I'll see you in the following episodes of this little series here. Until then, yeah, like, thanks for watching, and goodbye. Have fun with your shaders.